Geometry number 158, congruent circles, and I'm going to show you a little thing about inside and outside points of a circle. So, here we have two circles. It says, let's say this was a given, that line WX is congruent to line YZ. Well, that would tell you that these two circles are congruent. This is the radius. If the radius of this circle is equal to the radius of that circle, then the circles are congruent. There's actually a postulate for that. Two circles are considered congruent if and only if the radii are congruent. What it means is two circles are thought to be the same only if the lengths of the radii are the same. Okay? So you know there's going to be a proof probably coming up where you have to prove two circles are congruent. So that postulate will help you. So here's our little thing about inside and outside points. Did you know that you can tell if a point is inside or outside of a circle by the radius length? If the radius of circle R is 3 and the distance of point T is a 4 from point R, then it's outside because it's longer than the radius. If this is 3 and the distance or the line RT is a 4, then you know T has to be outside of the circle. Okay? Look at this one. If NM is equal to 5, if this radius is 5, and MP is equal to 2, then you know that it's inside the circle because the radius is a 5. A point measured of 2 would have to be inside because it's less than half the radius. So you could say that SR is not, we're supposed to have a line here, line SR is not congruent to NM. Okay? Circle R is not congruent to M. So when you see this, you know, remember that means not congruent. So line MP is 2, so the point is inside circle M. It's smaller than the radius. So just remember that when you're doing your proofs also. They might try to trick you or catch you, and keep your eye on the length of the radius, and that'll keep you on track. Okay? So, the next thing we're going to talk about is chords of a circle. See you there.